evaluate the integral, definite integral from 0 to 2, 3x squared minus 1. So we want to find the antiderivative, any antiderivative of this function, then evaluate at upper limit 2 minus lower limit 0. So 3x squared, we can use power rule. Antiderivative of xn with respect to x is xn plus 1 divided by same exponent n plus 1 when n is not equal to negative 1. Okay, so we can go in that way. Xn, 3 constant survives 3, xn, so xn plus 1, 2 plus 1, 3 over 3, and by the way 3 and 3 cancel. Or if you identify in this way, derivative of x cube is 3x squared. That means antiderivative of 3x squared with respect to x is x cube. So we can just write x cube, or going through this power rule we get the same thing at the end. Minus antiderivative of 1 is x, because derivative of x is 1. Now we want to evaluate this antiderivative. Plus c is not needed, from 0 to 2. Okay, this is pretty much x cube minus x. Now we evaluate this function at the upper limit minus evaluate the function at lower limit. So plug in 2 for x. So 2 cubed minus 2. 2 cubed is 8 minus 2. That's the upper limit part. Now 0 cubed is 0 minus 0. 8 minus 2, that's 6, minus 0, which is just 6. Final. To evaluate this definite integral, we use the fundamental theorem of calculus. For we find the antiderivative of these three terms, ignoring the limits, then evaluate the integral, that antiderivative, at the upper limit minus lower limit. So let's do it. What is the antiderivative of 2x? You can go for power rule, but give me a function whose derivative is 2x. That's easy. X squared, derivative of x squared is 2x. Okay, so that means antiderivative of 2x is x squared, minus antiderivative of ex is ex itself, because the derivative of ex is ex, plus give me a function whose derivative is 1, just identity function x, derivative of x is 1. So we found the antiderivative. Now plus c is not needed because we have definite integral. We go from negative 1 to 0. Evaluate this function at the upper limit minus evaluate at the lower limit. Replace x by 0. So x means 0 is square 0 minus e raised to 0, that's 1, plus x 0, that's the upper limit part, minus lower limit, this is coming from the formula, minus, replace x by minus 1. So negative 1 is squared, that's positive 1, minus e raised to negative 1. So this will be a decimal number, but we leave as it is, e raised to negative 1, which is same as the reciprocal of e, 1 over e, plus x equals negative 1. So plus negative 1 is just minus 1. Now I can see 1 and negative 1 cancel, 0 doesn't count. So negative 1 minus, and this negative and this negative, positive, e raised to negative 1 is reciprocal of e, 1 over e. So negative 1 plus 1 over e. We can combine, but that's not that important. So this is it. To evaluate this definite integral, we use the fundamental theorem of calculus. For that, we find the antiderivative of this function, then evaluate that antiderivative at the upper limit minus lower limit. So to find the antiderivative of this fraction, unfortunately we don't have a quotient rule, fraction rule, so we need to get rid of this fraction. We can split into two fractions and simplify from there. Let's see. So I'm just simplifying this fraction 0 to pi over 4. When we split into two fractions, this is 1 over cosine square. By the way, 1 over cosine is secant. So 1 over cosine square is secant square plus cosine square over cosine square, that's 1 d theta. So we have two terms. We find the antiderivative of secant square plus antiderivative of 1. So what is the antiderivative of secant square? That is, give me a function whose derivative is secant square. So tangent theta, right? Because the derivative of tangent is secant square. In other words, antiderivative of secant square is tangent. Plus 1. Give me a function whose derivative is 1. That's x, but our variable is theta, so theta. Okay, and we need to evaluate this antiderivative at 0 through pi over 4. So there are two terms, so upper limit minus lower limit. Replace theta by pi over 4 and you get tangent pi over 4. So what is the value of tangent pi over 4? Use the unit circle or your calculator, you get 1. So tangent pi over 4 is 1 plus theta pi over 4, just pi over 4 as a constant, minus, plug in 0 for theta, tangent 0 is 0 plus theta equals 0. So we don't have anything from here. So 1 plus pi over 4, that's the final answer. You can combine these two fractions, but that's not that important. So 1 plus pi over 4 final. Don't go for decimals.